So this is graphing systems of inequalities. To start with, I'm going to give you a quick little refresher on if you're graphing just one inequality, this one would be a line, so let's put it in slope-intercept form. And my solution set is going to be all the points that have their y values greater than negative x. So I can't just have a single point as my solution, I'm going to have a whole bunch, which means I'll graph this on my coordinate plane and shade all the points that work. So my boundary line between the points that work and don't is y equals negative x. It's a solid line because it was a or equal to. And then my line's not straight enough for me, hold up. And then to determine whether the points that make this true are kind of below and to the left or above and to the right, you can always plug a point in and test it. So I'm going to test a point. It can't be on my line, so I'm going to use 0, 1. So if I try that in my original, I'll have 0 plus 1 is greater than or equal to 0, yes or no. Yes, it is. So 0, 1 does work. That means I'm going to shade the half of the coordinate plane where 0, 1 is. So that's the part that's like above my line. So I'll go over and shade it. And that set of points, anything that's in that region of my coordinate plane, is a point that satisfies my original inequality. So yeah, that's how inequalities go. What we really want to do is a system of inequalities. So this is the same line that I had on my warm-up, so I just copied it to start with. I'm going to add a second line. It'll be dashed, and it's already in slope-intercept form, so I'm just going to go over here and graph my boundary line. It's dashed because it's strictly less than, so the points on it aren't solutions. So graphing it, I hate making dashed lines. And then I'm going to plug in a point and test it to see what side of that line I'm going to shade on. So I like to do 0, 0 unless it's on my line. So I'll have 0 is less than or equal to negative 3 when I get it all said and done, which is not a true statement. So I'm going to shade where 0, 0 isn't on the other half of my line, which is the kind of bottom right side of it. And then once I've got the shading done for both of my inequalities, the solution set to my entire system is just the points that make both of those true, so it's basically the overlapping region of your coordinate plane. So my solution set is kind of that triangle, shade it nice and dark so we can tell your solution set is any point that is in that region is going to make both of those inequalities true. So just graphing a couple of inequalities, seeing where they overlap at. This one, if you remember, something of the form like x squared plus y squared equals r squared is going to be a circle. Our center is at negative 1, 0, and since our radius squared is 9, our radius is going to be equal to 3. Let's go ahead and put the second line in slope-intercept form so that we're ready to go here. Subtract your 3x, divide by negative 4. Remember, if you divide or multiply an inequality by a negative value, you need to flip the direction of your inequality symbol. So boundary line is going to be y equals 3/4 x minus 2. Let's go back up and graph this circle. So center at negative 1, 0. I'm going to count out 3 units in all directions. And then I'll draw in my circle. Oh, hang on, wait, this is dashed line. Oh, dashed circles, so much fun. There we go, something like that. Now my points that work will either be inside my circle or outside my circle, because that's what my coordinate plane is divided into here, the two regions. So I'm going to try 0, 0 in as a test point. And if I do that, I end up with 1 is less than 9, which is true. So 0, 0, which is inside my circle, works. So all the rest of my points inside my circle do too. Yeah, my shading's not perfect, but we'll live with it. Let's graph our line. So y-intercept of negative 2, slope of 3/4. Count it out here. Another dashed line. And again, I'm going to test a point to see where I'm going to shade here. 0, 0 is my favorite. So if I do that, I'm doing it in the original. I'll end up with 0 is greater than 8, which is not a true statement. So the points that make that inequality true are the ones on the other side, where 0, 0 isn't, below our line. And then our solution set that makes both of these true is just that little sliver of my circle that's both below my line and above the outside of my circle. So my solution set is all those points in there. This is a good refresher on all of your different types of graphs. Hopefully remember that this one is going to be two parabolas. The first one is in vertex form, so your vertex is at -2, 1. And then we'll have to get some more points, so maybe plug in -1 and 0 would be another couple of good x values to use, which will give you 2 and 5. Plot them, reflect them, and solid line so much nicer than dashed line. Okay, there's my first boundary. Let's test a point. Going with 0, 0 again, classic. If you plug that in, you're gonna get an inequality that is true. So the set of points that make that one work is below my parabola, where 0, 0 is. So there's a lot of region to shade here. Let me try and not do a terrible job of it. All those points that are not above and inside of my parabola. My second parabola is not in vertex form, it's in standard form. So to get my vertex, I'm gonna have to do the x equals -b/2a, which if I plug those values in, is gonna give me an x coordinate of 1/2. If I plug that 1/2 back in, I'll get 1/2 from my y value as well, and then a couple more points. So I did 0 and -1, and got 0, 0, and -1, -1, 4. Plot them. And then, oh, hold up, I had to think for a second about how far to go here. And then if you test points once more, I can't do 0, 0, so let's pick another point instead. How about 1, -2? I can tell that that would be inside my parabola, so let's see if it works. Gonna get a statement that is not true, because -2 is not greater than or equal to 0. So I need, again, all the points that are above and outside that second parabola. So my solution set, when I get all this shaded, that works for both inequalities is the points that are outside of both parabolas, basically. It's the purple part in the middle between the two. Saved the easiest, I feel like, for last, even though it has 3 different inequalities. They're horizontal and vertical mostly. So the first one is just, if you think x equals 2, x equals -2, the boundary lines are vertical, and it's all the points that have x values between -2 and +2 is what that inequality says. So those points are in between those 2 vertical lines. Second one is, if you think y equals 1 as your boundary, a horizontal line. And if we're talking about all the points that have y values bigger than 1, those points would be above that boundary line. Last but not least, we have y is less than x, which is just plain old line with a y-intercept of 0, 0, slope of 1. You could plug a value in and test it. Say that we pick 1, 0. You'll have 0 is less than 1. That is true. So we'll be shading where 1, 0 is, which is below my line. So if you can figure out where all 3 of your shaded regions overlap, it's that little triangle in the middle there. So your solution set is just that set of points that fall in that region. All right, that's kind of the basic idea. Let me talk about for 1 second this one that I had for you to try. If you graph two inequalities and none of them overlap, it's no solution.